All right, so while you're stretching and starting to sit down, welcome to our presentation on a metadata-driven framework for data discovery and data trust. I think our thing's not working. Maybe it's the other one. We'll see if this works. Beautiful. All right, I guess we've had the intros, but once again, I'm Akira. I'll be talking about data discovery. Mr. Xinwei should be talking about data trust. So let's go through some of the well-known stresses of data. For example, what data do we even have? And likewise, can we even trust this data? I'm sure our fellow analysts and stakeholders, they probably ask themselves this question every day, right? So we thought, okay, why don't we help them? So welcome to data empowerment, which is the outcome-focused data management. And for us at Afterpay, this is to help data consumers find their data easily and ensure that they can actually trust the data. Now, because our team was relatively new, let's say 4 to 6 months ago, we've had two sizable challenges that we've faced. The first being limited time, right? We've got all these users and analysts who are suffering these problems every day. They need a solution now and not 3, 4 years down the track. And likewise, resource constraints. And actually, for the past 4 to 6 months, the team has really just been me, myself, and I. Xinwei and Nam, shout out to you guys. They've helped us from time to time as borrowed resources. But yes, that means our approach had to be efficient. And that is, we're going to reuse what we have and build what we don't. So let's go through the technical architecture at a high level. Very standard pipeline. We've got our source system, which then goes through ELT jobs to bring the data in, dump it into a data warehouse. You've got some data consumers who use their BI and SQL clients to run their queries. Now, when they have questions, and they always do, right, they go to Slack. If you've never heard of Slack, it's our method of communication. Think of it as an alternative to Microsoft Teams. Now, we do have source data, let's say subject matter experts, but they only answer questions on a best effort basis. So I'm sure we all know most of the time, in fact, all of the time, it's us to ask poor data engineers to answer these questions on our very busy schedule. So we decided, okay, we need a process to automate or help automate the answering of these questions. So we decided to create a metadata collection DAG, which uses Python, Spark, SQL, and Airflow. And to kickstart off this DAG, we decided to grab all the metadata from our data warehouse, which is Redshift. So we hit the system views. Now, because it is, let's say, a bit intense in computation, we hit it at night where it doesn't really impact other critical jobs. We then grab all the job statistics from Airflow, the metadata database in the back end, and we grab things like performance, runtime, schedule. Were there any errors? Awesome. We've got some basic metadata and statistics. But now we've got all these Slack questions, and we're like, okay, how do we automate the answering of these questions, or at least make our lives a bit easier? So, things like, where is the data? When is it available? Who knows about that? So many questions, not enough time to answer. So we decided to create a Slack analysis DAG, and I'll talk about it in the next slide. But for now, just take my word for it. Now, this DAG then dumps everything into a central metadata database, and it's in Postgres, mostly stored in third normal form, and hopefully anything can integrate with it. It's interoperable. And then we reach our final goal, Amundsen, the great explorer. But some of you are like, okay, well, what is Amundsen with respect to, let's say, technology? Well, Amundsen is an open source data discovery metadata catalog platform. And why did we choose it? Well, if we go back to our approach before, it's to reuse what we have and build what we don't. And now we just had Amundsen sitting there at Afterpay as a proof of concept image. And we're like, okay, we don't have time, we don't have resources. Why don't we just experiment? Why don't we hedge our bets on it, let's say, right? And so we chose it. And the cool thing about Amundsen is that it allows users to search for data. And it uses Elasticsearch. They can search for any table, any column, schema, and so on. And even better, it allows us to crowdsource data, right? You can allocate data owners on Amundsen, and then it's up to them to fill it out. All the stuff that's stored in their brain or on a Confluence page no one reads about, we can chuck it onto a central location for everyone to see. And that's one of the key features of data discovery. And to top it off, we can also open up our central metadata database to integrate things like BI dashboards, let's say using Looker or Tableau. And you can open up APIs to other apps to use as well. So it's not just for us, but it's for everyone. Awesome. So somewhat, the data consumers are happy, they've got their questions answered, and hopefully they're empowered to do the work. So let's talk about the Slack analysis DAG at a conceptual level. right? And this is to automate the answering of questions because we hate answering these questions, right? It goes through our busy schedule. So rather than asking users to fill in a quarterly survey, like, how long did you spend on average getting your questions answered? Did they even answer your questions? We're like, okay, rather than wasting the analyst's time, we'll just automate it. So we decided to grab everything from our data support channel, which is hashtag AP Data Support on Slack. So we grab all the latest questions, all the latest threads, whatever. And then we apply some very simple natural language processing. Things like, okay, categorize the type of question. Is it to do with an error? Is it to do with where is the data? When is the data available? All those kind of questions, right? And then we also apply some regex to extract some objects. And an object at Afterpay is any table, any view, any schema, column, database, and so on. We extract all of that information. And then we apply a very simple tagging and matching process back with our central metadata database. And this allows us to connect any data support question to any user who asked it to any object in our whole system. So it's pretty neat. And one of the key results we get is a simple dashboard that anyone can use, even up to the leadership team. And that's to prioritize metadata collection based on usage. So on the left-hand side, you'll see there are object priorities and the number of questions asked in Slack. And hopefully you can see a very simple solution already, right? Which is, okay, this table or this object has been asked 33 times. Why don't we prioritize the metadata collection for this table, right? Because the more metadata is available for everyone, hopefully the fewer questions will be asked. We definitely hope that's the case. Likewise with the problem categories, right? Let's go through knowledge as an example, right? A big chunk, 76 questions asked since February. Why don't we prioritize allocating data owners, filling in column descriptions, filling in table descriptions, so less people ask, who knows about it, what is the data, and so on. So to tie data discovery together, I just wanted to go through business as usual day at Afterpay using Slack and Amundsen together. The first scenario, we've got an analyst going, hey, I'm trying to join these two tables together. What's the business logic? Who knows about it? And then you've got an engineer who responds, okay, here's two links to Amundsen, just like that. And in fact, Amundsen displays information about the most frequent users, like who queries the table, which analyst does that. So we tag those people as part of the data support thread as, let's say, additional support or future reference. And in scenario 2, we've got a self-service check data command. So analysts can go, okay, check data, input schema.table name. They get back the latest data quality checks, as well as a hyperlink to Amundsen for the latest metadata. So let's go take a look at the Amundsen UI, shall we? Here we go. Now at the very top, you can see the search bar that uses Elasticsearch. Search for anything you want that's available. And just below that is a preview. We've got the schema.table name. You can bookmark your favorite tables or views. There's a few badges. I'm not sure if you can read, but the top one on the very right is a view. So this is actually a view that we're talking about. Below that to the left, we've got programmatic description fields. So free text description fields, anyone can change an input, and we track those changes. There's also a metadata score that we've invented, as well as hyperlinks to Anomalo, which Xinwei will discuss. But the cool thing is, we've also got information on our Slack data support. For example, we can actually see that this view that I've got right here has appeared in our data support channel 46 times since February, and we've also hyperlinked the latest thread, right? Because the people who are interested in this table should be kept in the loop, right? They want to see the latest questions asked. On the right-hand side, we've got information about columns. In fact, we've got 73 columns in table. Each column has a free text description field where applicable. We've got things like data precision and data types, as well as badges. Was this a partition column because it came from an external table? Is it a joining key to another table? Things that, a lot of this stuff we don't know, as well as, let's say, business date keys, all the useful information. So that's data discovery in a nutshell. I'll hand it over to Xinwei to talk about data trust. Here you go.
Thank you, Akira. So now we found data in our Amundsen and did some data discovery work. The next question people will ask is, can I trust this data? First, we believe transparency builds trust. In our framework, all the metrics or data quality checks are transparent to our user. If we keep all the metrics within the engineer team, then in the future, all the requests will come to the engineer team. This is not scalable over time with business growth. Then our second idea comes out. Data quality is everyone's responsibility rather than only engineers. However, sometimes it will turn out to be no one's responsibility. So in order to decentralize our data quality check and derived from research published by Dharma UK in 2013. 2 types and 6 dimensions are applied into our framework. The first type is operational type. It contains timeliness, completeness, and uniqueness. Those 3 dimensions are usually static, and our engineer team is responsible for those 3 dimensions. Based on our ETL jobs, our engineers can easily measure whether all data is refreshed and available on time, whether all received data is ingested into our database, and they also can check the unique value for the primary key column. The second type is business type. It contains accuracy and consistency. So those 2 dimensions are usually changing over time with business growth, which means our data consumer is responsible for those 2 dimensions. The 6th dimension is validity. It is a shared dimension across operational and business. Our engineer can have some validation checks on data types or non-value, and our data consumer can have their own validation checks based on their own business rule. Now we know that everyone can have a data quality check. The next question will be how. How we can create data quality check. Anomalo is an existing tool in our company, and it perfectly fit our purpose. First, it has a very simple UI. Our user can easily create their data quality check through ClickOps. And it also has a lot of user-defined key metrics and validation rules. So the key metrics are the checks that monitor the key business metrics. For example, column sum is not anomalous. Column 0 value count is not anomalous. For the validation rule, it is the check that are the expectations about data. For example, column value fall into a range, or column is always greater than another. The third key feature is the automated data profiling. Before our user to use the table or design their own data quality check, they can always go to the Anomalo UI to see the table structure and check some sample data. Last but not least, our API connectivity. All the data quality checks can be created or updated through Post API. And also, in our framework, we rely on the API to collect all the rule details and check results. So here is some example. This is a UI about how we can configure a table on Anomalo. Basically, we just need to fill in the description, set the schedule, and also pick a date column if you want to run your check based on certain date, and also pick the notification destination. Then all done, and then 8 automated baseline check will be set up, which fall under our operational type. In order to store all our metadata into a central database, API and Python SDK can be used in our ETL processes to collect all the rule details and check results. Here we show how we integrating Anomalo with our framework by using simple API connectivity. When ETL jobs ingesting data into a new table, a Post API can be used to configure a table on Anomalo, and then our metadata collection deck can use a GET API to collect all the rule details and check results and store in our central metadata database to connect the dots between the data quality check and business context. So here are the 8 baseline checks in Anomalo. So data freshness for timeliness dimension, data volume for completeness dimension. It also has check on missing data, table anomalous. Our Anomalo also offers a lot of different metrics. For example, here we have row counts, column unique values. Anomalo also provides a lot of information on the field checks. In this example, you can see the green area is the prediction interval, and our actual value, which shows in red, is much lower than the prediction. Then there might be something wrong, and we have to do some investigation. And our API will return the same information. It told us the check was failed and which column caused the issue. Now we addressed the data discovery issue and the data trust issue so far. The next challenge is how to measure how well are we doing. Then a concept called the weighted score come into our framework. The weighted score for data discovery is the metadata score, which measures the completeness of the metadata fields. And for data trust, the score is the total number of field checks versus the total number of checks at an object level. So let's do some math. So a score at a high level is a metric between 0 and 100. For data discovery, the metadata score is a weighted sum of how much metadata is available, and the variance is the portion of non-metadata fields over the total number of metadata fields. For data trust, the score is a weighted sum of how many checks passed, and the variance is the portion of the number of field checks over the number of total checks. This is the dashboard we are using right now. This is the metadata scores. In this example, you can see that the objective metadata score is 55.86, and it measures how complete is the objective metadata. And our overall metadata score is calculated from the source score, object score, and column score. We hypothesize that if the score goes up, then our user can find more data easier. And we also have the historical snapshot of the score over time to monitor the long-term trends. And we also can measure our team's progress by KPIs and also assign KPIs to other teams to improve the metadata scores. So, and integrating our framework with the low-level detail from Anomalo, a high-level insight will be provided to the leadership team, and our data quality score can be used to help to set the goals or objectives. In this example, you can see that most of our scores are around 100 or 99, which means we're doing things right. And if the trend goes down, then which means there must be something wrong and we have to fix it. So before I talk about our big wins, I just want to emphasize that we just start our work 4 months ago. So our first win is around 30% of data-related questions we can use Anomalo and Amundsen to answer in the past months and save a lot of time to investigate. Our second win is over 1,400 metadata fields are collected. And our third win is we enhance the user experience with transparent data metrics and self-serve capabilities. This is our future roadmap. A lot of interesting improvement and amazing projects are waiting for us, such as context-driven search, predictive model, and metadata chatbot. So if everyone is interested in our team or keen to know more information, please see us at the booth, and we are waiting for all of you. Thank you for listening, and this is our presentation. If you have any questions, feel free to ask.
Great presentation, both of you. That was fantastic. I'm interested to know with your usage of Amundsen, I'm assuming that it's not purely metadata that populates it, that you're also enriching data through users adding in their own data. How do you find users being able to do that, encouraging them to do that? Often it's not something that they'll benefit from, it's the other person that will benefit from. So how do you encourage them to enrich that data so it's useful to the entire organisation?
Yeah, I can answer this one. So the thing with Amundsen is that it's just any tool that sits on top of our central metadata database. So if it disappears, first of all, it doesn't really matter. We just plug something on top. Now, in terms of what metadata has been added, there's an underlying Neo4j database, so it's a graph database, and we can actually export that stuff. We can capture it through an API and actually sync it back to our metadata database, and it doesn't take that much effort. Now, in terms of actually populating the stuff, generally speaking, right, it's for the analysts. At the end of the day, it's going to help them and the future people that come on board, right, the onboarders, because I'm sure we've all onboarded our companies like, oh my God, like, where do I start, right? So Amundsen is their go-to. So generally speaking, the metadata they populate will be as accurate as possible from their knowledge, and it's going to benefit everyone. And so the ways we promote this is, first of all, we just send it to an analyst. If they ask a question like, all right, here's Amundsen, if you find an answer from the frequent users of the table or you've talked around, please add it in for future. And in fact, that's where the 1,400 fields come from, right? They've just added in over time without us asking. In our future, we plan to do things like a hackathon, right? And it's kind of like, okay, you win a pizza, you spend a whole day just populating as much metadata as you can, right? And it's beneficial. It's a win-win for everyone. It's a win for us because, yes, we get more metadata. And it's a win for the teams because now they don't have a Confluence page sitting there in the archives, and it's just on Amundsen. And if we get rid of Amundsen, it's still in our central metadata database, and we can track all the history, all the changes, and who it was done by. Does that answer your question?
Yes, well, it does. Thank you.
No worries. Yeah, so to answer that, I'm actually not the infra guy. I'm the technical guy who does everything onwards. So if you want the infra stuff, please see us at the booth. I'm sure someone can answer that for you. Sorry about that.
Hi, fantastic presentation. Thanks for that. And how do you handle data linkage between the harvested metadata and the source systems? Because most of the times, the columns that we have in source system and the way it get transported to different layers, it gets transformed and the name changes occurs. So how do you handle that data linkage?
So I think data lineage by itself is a whole topic, right? I could spend a whole day talking about it. But in fact, if you want a brief overview, we do have a process to calculate lineage. And the cool thing about our process, I didn't have enough time to talk about today, is we actually have a process which updates metadata in a bidirectional manner. And we've got lineages for 93% of our engineering tables that we own. So for example, if you've got an upstream table and an engineer just populates one field, that will propagate all the way downwards. And the process we do is just very simple Python processing. We look at the DDLs and host it on Redshift and all that kind of stuff. And naming conventions are pretty important. Hopefully that kind of gives you an idea. If you want more talk, we can go to the booth and discuss it. Yeah, thanks.
Can I just follow up on that? How often do you run those jobs?
So most of the jobs are daily, but a lot of them are also just like run on a need-to basis because not many things update. But the things like objects and columns available, all that kind of stuff, that's just from Redshift directly. And if it doesn't work, it's okay if it fails one day because it's going to eventually be consistent. So it's not critical. Boohoo, if it dies one day, we just rerun it when we need to. And the aim is, hopefully it's eventually consistent because metadata is not always going to be, there live, right? It's impossible, I think. But eventually, consistent, yes, very possible.
I just had a follow-up question to that. So is there like a scanning capability to ingest the metadata and the lineage from various key applications to the central repository? Because when you said that we can write jobs to keep on updating the metadata, because as you know, in today's world, it's so dynamic. We have so many technical implementations. There are database upgrades, and sometimes there are transition to the cloud platform as well. So personally, from my experience, we find it very hard to keep the metadata in key systems consistent with what we have ingested in the repository. So just wondering if there is like a auto-scanning system and we can schedule the batch jobs and the metadata just keeps on uploading to the repository to be consistent with what metadata is contained in your key applications.
Okay, yeah, so right now, let's just say if it's a daily job, right? So every morning, just before the business starts for the average Afterpay user, everything's populated, all the lineage, it only takes a few minutes because it only updates when it needs to. And once it's updated, right, it doesn't really need to change, especially with the column descriptions. It's more of a once-off thing. So yeah, we do have a daily job that runs in the morning. And once it's updated, we have a history of it, and that's it. So I would say, yeah, it's not up to date in terms of live, but it is up to date just for enough for the users to do enough for the day. And we only just started, so for now, we think it's good enough. Yeah.
Okay. Very good presentation. Thank you.
Thank you.